Hello students, how are you? I hope you all are doing well. So students, I hope you revised the whole concept of your previous chapter, and now from today onwards we will start a new chapter which is exponents. This is our chapter named exponents. So while we are talking about the exponents, you can simply say the power of the numbers. Okay. For example, we can also relate with it exponents because in earlier classes we already learned about this chapter, but this is a new chapter for this class, so we will start with it. So in the previous class, you have learned about positive integral exponents of rational numbers and the laws of these exponents. In this chapter, you shall learn about negative integral exponents, their laws, and the use of exponents to express small numbers in a standard form. We start with a brief review of your previous knowledge. So this is time for recapitulation. What we mean by recapitulation? We have to brush up our previous knowledge. So if a is any rational number and n is any positive integer, then a multiplied by a multiplied by a multiplied by a and furthermore more. So it means that if we multiply a n times, n it's not a finite value. Now n is unknown value, so we can say a to the power n. So a to the power n is called the power nth power of a and is read as a raised to the power n. A raised to the power n. So, the notation of writing the continued product of rational numbers by itself several times is called the exponential notation. It means that while we have a same number and we multiply it to itself by n times, it simply means a exponent notation or power notation. The number that is said to be multiplied by itself, it's called the base, and the number of times it is multiplied with itself, it's called the exponent or index or power. So we have three terms for using this power notation, which is exponent, index and power. So a raised to power n, a is the base and n is the exponent. So you have learned the following laws of exponent. Here now we have these laws of exponents which we have to keep in our mind to solve this chapter correctly and in a simple way. So if a and b are non-zero rational numbers and m and n are positive integers, then a raised to power m multiply a raised to power n is equal to a raised to power m plus n. It means that when you have same base a and a, you can simply add the powers of those bases. So the power of a is m and the power of this a is n. So what you do, take the common base here and add these two powers together. Next we have a to the power m divided by a to the power n, which means the common base in division. While we study about the multiplication, the first we have a study in our earlier classes. Multiplication means repeated addition. So while we have multiplication, so you have to add your values. When we have division, which means repeated subtraction, so we have to subtract our values. Okay. Next, when we have a power inside the bracket and a power outside the bracket, and bracket means off. Off means sign of multiplication. So what you say, a to the power m multiplied by n. You have to multiply these two values together, two powers together. Now a m in the bracket to the power n. It means the a and b both have the same power, which is n. A to the power n and b raised to power n. Now a by b to the power n in the bracket, it means both the numbers a and b have the same power. Zero exponents. If a is any non-zero rational number, then a to raised to power 0 is equal to 1. If you see any number which having a value or power of 0, so what you have to do here, you have to simply take that value as 1. Now, negative integral exponents. Look at the following exponents of 10. 10 to the power 0. 10 raised to power 0, which means 1. 10 raised to power minus 1, which is 10. 10 raised to power 2, which means 100. 10 raised to the power 3, which means 1000. 10 raised to power 4, which means 10,000, and so on. As the exponents of 10 increases by 1, the value becomes 10 times the previous value. In other words, as the exponents of 10 decrease by 1 from 10 to the power 4 to 10 to the power 0, which the value becomes 1/10 of the previous value. So, as you increase the numbers, as the numbers are increases by itself, in this one, in this one, 1 0, 2 0, raised to the power 3, 30 raised to the power 4, 4 zeros. You can simply say that. Okay. Now, continuing this pattern, we have 10 to the power minus 1, which means 10 to the power 0 upon 10 to the power 10, which means 1 upon 10. If you have any power in negative notation, it means that you have to take those numbers like in this form. So 10 to the power minus 1 means 1 to the 1 by 100. 10 to the power minus 3 means 1 by 10 to the power 3. So for converting this negative value into a positive value, you have to convert it in that form also. So 10 to the power 0 is 1, 10 to the power 2 is 4, 10 to the power 3 is 8. You can observe the pattern that has the exponents of 2 increases by 1, the value becomes 2 times of the previous value. If you move from 2 to the power 4 to 2 to the power 0, you can see that the exponents of 2 decrease by 1. The value becomes half of the previous value. Continuing this pattern, we have 2 to the power minus 1, which means 2 to the power 0 and 2 raised to power only 1, to 1 by 2. 1 by 2 to the power 2. 2 raised to the power minus 3 means 1 by 2 raised to the power 4. Now, thus we have the following definition. Negative integral exponents. For any known zero rational number a and a positive n, a to the power minus n, which means 1 by a to raised to the power n is equal to 1 by a raised to the power a. In other words, a raised to the power minus 1 is the multiplicative inverse of a raised to the power n. Okay. Now for this one, how can we convert this? Minus 3 here, so we have to convert in this form. So 1 by 5 to raised to the power 3. Minus 4 raised to the power minus 6. So 1 upon minus 4 raised to the power 6. In that case, what you have to do now, the number minus value remains same, but the exponent, the power value sign of it will remain into opposite of it, matlab minus to positive. Now express the following as rational numbers in p by q form. So 1 to the 1 by 7 raised to the power 2. 1 by minus 3 raised to the power 4. In that way, you can simply change it, and you can expand it also. 7 multiplied by 7 is 1 by 49. 3, if we multiply 3 4 times, so we will get 1 by 81. Okay. Now next we have simplify this. So again, 2 by 3 to the power minus 3, 3 by 5 to the power minus 2. So you can simply do 1, 2 to the power 2 by 3 to the power 3, 1, 3 by 5 to the power 2. You can take like this also, or you can end of the moment now you will get the reciprocal of this number in positive. So 2 by 3, 8 by 27, 9 by 25 while you changing it, and the reciprocal of it. 27 by 8 multiply 25 by 9. The end result is 75 by 8. 3 by 2 to the power 3 multiply 5 by 3 multiply 5 by 3 raised to the power 2. Now you can simply solve it, the result will remain same. Okay, it's totally up to you. If you want to solve this question like this, you can do this, will you get to the correct answer, and this process is also get you to the correct answer. Now exponents and decimal numbers. Consider the exponent form of any decimal number, say 89.417. So how can you expand it? 8 multiplied by 10, 9 multiplied by 1, because this is 1s, this is 10s, 0.4 plus 4, 1 by 10 plus 1, 1 by 100 plus 7, multiply 1 by 1000, because after the decimal point we have tens, 100 and 1000. Okay. The same way you have to expand this number as well. Now laws of exponents. So you are already familiar with the laws of exponents. When the exponents are positive integers, these laws hold good even when the exponents are non-positive integers. If a and b are non-zero rational numbers and m and n are any integer, then these are the laws I already explained you in the starting of this chapter. So you have to revise those laws again here. Okay. So we will do it with the exercise while doing a question particular to that formula. So the first one, now we have example. So simplify the following and express in exponential form. We have common base 6 and 6, minus 5 minus 7. We have sign of multiplication. It means what we have to do? We have to add these values together. Minus 5 plus 7 is minus plus minus, so 6 to the raised to the power 2. Again 3 by 8 to the power 2, and this is minus, so we have to reciprocal of it. Oh sorry, so we have multiplied, so this same, this 2 plus minus 4 minus, so 3 by 8 raised to the power minus 2. Now we have division, means we have to minus 9 minus 3 minus plus, so minus 9 plus 6 is minus 9 plus 3 is minus 6. So 1 by 5 raised to the power 6. You can simplify this. Now 6 by 7 raised to the power minus 3 multiply 7 by 6 raised to the power minus 5. So we have to reciprocal of it. So 6 by 7 raised to the power minus 3. Reciprocal of 7 by 6 is 6 by 7, and the negative power will convert it into the positive power. So 6 by 7 raised to the power 5. Now you can simply take your common bases here. There is a sign of multiplication, which means we have to add these values together. Minus 3 plus 5, your answer will be 6 by 7 raised to the power 2. And further, while you expand these numbers now, to 6 multiplied by 6 to 36, 7 multiplied by 7 is 49. So here is your end result. Okay. So in that way, you have to apply those laws which we learn in our chapters in starting, and apply over these questions, and you simply get your answer. So simple. Okay. So 6 to the power 7, 6 raised to the power 7 divided by 6 raised to the power m is equal to 6 raised to the power 10. It means we have a division, and division means we have to minus. So which number we have to minus? So we will get 10. So we have to minus 7 from that number. It means you can simply say 7 and it will be go there. So it means 7 minus m is equal to 10. M is equal to 7 minus 10 is minus 3. So when we have minus 3, so we will get 10. Okay. By what number should 3 raised to the power minus 2 be multiplied so that the product may be equal to 5 raised to the power minus 1? So 3 raised to the power minus, let the required number be x. So 3 raised to the power minus 2 multiplied by x is equal to 5 raised to the power minus 1, which means 5 divided by 3 raised to the power minus 2. 1 by 5 divided by 1 by 3 to the power 2. Solve karoge aap. When you solving it, so you will get 1 by 5 multiply 3 to the power 2, which means 9 by 5 is your end result. Now we have exercise 2.1. So this is time to applying all concept knowledge over the question. So express the following as rational numbers in the form of p by q. So this is a negative power. How we'll convert it into positive one? 1 by 3 to the power 3. In that way, 1 by minus 2 to the power minus 5. So you have to solve the rest of the question in like same manner. Now simplify 3 by 4 raised to the power minus 1 and 2 by 9 raised to the power minus 1. So we have different bases. So we cannot directly add these numbers together. So what we have to do, we cannot simplify it further. Direct multiply it, reciprocal of it, 4 by 3, so it will convert it positive, then 9 by 2. Now directly multiply these two numbers together. 4 9s are 36, 3 2s are 6. Here is your answer. Further will you converted it, so it will be get you 6 only. Okay. Now 5 minus 1, 5 raised to the power minus 1 plus 4 raised to the power minus 1 minus. So what you have to do? First, we have to convert it these numbers. 1 by 5 plus 1 by 4. Okay, and then further it will convert it into positive. Divided it 1 by 3 to the power 2. Now can you simply simplify it now, because you now understood how to. First you have to take the LCM of it, which is 20. So write here 20. Multiply the numbers with the numerator as well, which you multiply with your denominator. So here you multiply 4 and here you multiply by 5. You will get 9 by 20. Now divide it. So for division, 1 by 3 multiply by 1 by 3. So 3, 3, 3, 3. 1 by 20 is your end result. Okay. So you will get here 1 by 20. In that way, you have to solve rest of the questions. Now simplify the following and express the result in exponential notation with positive exponents. So you have to represent your end answer at in the positive exponent. So 4 raised to the power minus 5 and 8. So first what you do? Minus minus plus. So your end result is minus 8 and we have to convert it into the positive norm. So 4 raised to the power 8. Now 4 3s are 12. So 8 by 9 minus 12 is the power. How we can convert it into 9 by 8 raised to the power 12. You can simply solve these questions like that and solve it the rest of the question in the same manner. Now simplify it. So 2 by 3 and 3 by 2. So what we have to do? 2 by 3 minus 2 multiply 3 by 2, the opposite of it, the reciprocal of it is 2 by 3 raised to the power 1 only. Now solve it. Minus 2 plus 1, so your answer will be 2 by 3 raised to the power minus 1, and this value 2, the outside of the bracket. Now we have to multiply minus 2. So your end result is 2 by 3 to the power 2. So this is your end result minus. Okay. Next question. 25 raised to the power minus 2 divided by 10 raised to the power minus 4 divided by bracket value is minus 1. So 1 by 25 raised to the power 2 divided by 1 by 10 raised to the power 4. First you have to solve it and then you will get your answer. Now find m if 7 by 12 raised to the power 6 multiply 7 by 12 raised to the power minus 10. So your bases are same. The common base you have to write here. There is a sign of multiplication, which means 6 plus minus 10 and your result is minus 4. So the m value is equal to minus 4. The next question is find m if minus 4 by 9 raised to the power minus 3 divided by minus 4 by 9 raised to the power minus 2m is equal to minus 4 by 9 raised to the power minus 9. So what you have to do? Minus 3 minus 2m is equal to minus 9. These are the power of these bases. So I'm not taking the base. I'm just working over the powers. So minus minus plus, so minus 3 plus 2m is equal to 9. 2m is equal to 9 if it is this side is negative, so while we changing its side it will convert it into positive. So 2m is equal to 12 and m is equal to, we can check it, minus 3 minus 2 multiplied by m is 12, so minus 12 and minus. So first we try to check it. Minus 3 minus 12 minus 6 is equal to minus 9. Minus 3 minus plus 12, and when you solve it, so you will get minus 9. Here is your answer. Next we have, by what number should be 6 raised to the power 2 be multiplied so that the product may be equal to 15 raised to the power minus 1. So which number we have to multiply 6 raised to the power minus 2 to get 15 raised to the power minus 1. For this, first we have to convert this 6 raised to the power 2 multiply x 1 by 15 raised to the power 1. If we change it, so x is equal to 1 by 15 multiply 6 into 6 upon 1. First you convert it into 36 upon 15. If you divide, you will get your answer. Bachcho, I already explained you these questions in this type of examples already. So if you have any doubt, so what you have to do, you have to keep this example, solve it one more time, you will get your answer very quickly. By what number should be 3 we multiply? So what we do? 3 minus 2 multiply by. So these your number. First you convert it like this, the same way I am doing here, and solve it. You will get your answer. Okay. Now what number should be 8 by 3 raised to the power minus 1 be divided so the question may be equal to 4 by 3 raised to the minus 2. So I already explained you how you have to solve this question, so you can easily solve it. So use of exponents to express small numbers in standard form. You have learned to express large numbers in standard form using exponents of 10. At times you may come across very small numbers. For example, the average diameter of red blood cells is 0.0007 mm. Thickness of this sheet of paper is 0.0016 centimeter. The size of bacteria is 0.000005 meter, etc. Now you shall see how can very small numbers be written in standard form using negative exponents of 10. To write a number in standard form, you have to express it as the product power of 10 and a decimal number greater than equal to 1 and less than 10. So a multiplied 10 to the power 6, where 1 is smaller than a is smaller than 10 and b is an integer. So how can you represent these numbers? This is your number in decimal. Now you have to count the numbers. How many numbers you have after the decimal point? So let's get started. 1, 2, 3, 4, 5, 6. So you have to put here 6 zeros. Now 7 by 10 and here we have 6. So 7 multiplied by 10 raised to the power minus 6. How many zeros you have in the denominators? So simply you have to put that value as the power of 10. So here we have 6 zeros, we have 10. So we just simplify it. 10 raised to the power minus 6. If you have the zeros in the denominators, then your power should be in negative. If you have zeros in numerator, then your power should be positive. Okay. In the same way, you are solving these two questions as well. So how many zeros we have after the decimal? 1, 2, 3, 4. So 4. So 1.6 10 to the power minus 4. Here is your answer. Now do one thing. Now you are applying a point over there. If you are applying a point over there, it means you are taking 1 0 from it. So it means when you have 4, so you have to minus 110. So it means 1.6 10 to the power minus 3 is your end answer. It is easier to compare numbers when they are in standard form. While we writing these numbers now, we can easily speak out these numbers. We can easily compare this number. That's why you using this standard form. To compare the size of red blood cells, which is 0.00007 m, and the size of plant cell, which is 0.00001275 m meter, we first write them in standard form. So these are the standard form of red blood cells and the size of plant cell. So now you can easily compare which one is bigger. So we can put it like that also. So 7 multiplied by 10 to the 10 raised to the power minus 6 and 1.275 multiply 10 raised to the power minus 5. So while this 10 raised to the power 5 will convert it your denominator into numerator, so it will be converted positive, the reciprocal of it. So you will get 7 multiplied by 10 raised to the power minus 1, 1.275, and here is your end result, which is by 2. So with the help of notation form, with the help of standard form, you can easily compare it, calculate it, the difference of it. So the size of a red blood cells is half of that of a plant cell. To add or subtract numbers given in standard form, convert them into numbers with the same exponents. For example, if the diameter of the sun and the earth are 1.4 multiplied by 109 meter and 1.275 multiplied 107 meter respectively, then find the sum of the two diameters. So you can simply converted these values into the standard form, and now 140 plus multiply 10 raised to the power 7 plus 1.275 multiply 10 raised to the power 7, and here is your end result. So students, now we will get to start our next exercise, which is 2.2. So are you ready? Okay. So express the following numbers in standard form. We already do it, right, in our previous concept. So let's count the numbers. How many numbers we have after the decimal? 1, 2, 3, 4, 5, 6. So 4, 7, 10 raised to power minus 6. But we are putting a point over there, which means 4.7 multiplied 10 to the power. We are applying a point over there, na? So 10 to the power 7. Now 1, 2, 3, 4, 5, 6, 7, 8. So 8 multiplied 10 to the power minus 8. Okay. Write the following numbers in the usual form. So we have to write these numbers in usual form. So 7.5 multiplied by We have to apply 4 zeros because 10 to the power 10 raised to the power is 4. 1, 2, 3, 4. Now we can remove this point to 7, 5, 0, 0, 0. So 75,000 is your final answer. Okay. If the mass of the earth is 5.97, multiply 10 raised to the power 24 kg, and the mass of the moon is 7.35 multiplied 10 raised to the power 22 kg, what is the total mass of the earth and the moon? So what you have to do, you can simply 5.97 multiply 10 raised to the power 24, 7.35 multiply 10 raised to the power 22. Now 5.97 7.35 multiply 10 raised to the power 24. This value is in positive, so while we're converting into upward, so it will convert it into negative and you will get 10 raised to power 2. Now these two values are also removed. So with the help of 7's table, 56, 337 it's not possible, 49 and 7 that is possible, 7 1. So 7 1 1 is your answer. Here 1 0 5. So this is your end result. So now you convert it further. 3 9 and 6 2 1 not possible. 7 1 1 1 0 5 10 raised to the power 2 is your final answer. So in same way you have to solve rest of the question. I already explained you in example part how you have to solve this question. So if there are any doubts, what you have to do, you have to go over there where you have your examples, you have to learn it again, keep the concept in your mind, then you come back to your exercise and try to solve those questions which you are not able to solve. Now the things which we have to remember while we solving this chapter, if a is a non-zero rational number and n is any integer, then a raised to power minus n is equal to 1 by a raised to power n, which is positive. So 1 by a raised to the power n, you can say simply. If a and b are non-zero rational numbers and m and r are the integers, so these are the laws which we already discussed in earlier in our chapter. So you have to keep these laws in your mind, otherwise this chapter will become a difficult task for you. Now, very small numbers can be expressed in standard form using negative exponent. So, when you have numbers which are in the decimal point, so how can you express those numbers? You can simply express those numbers in the negative exponent. So, student, this chapter is ends here. I hope this chapter is clear to you. If you have any doubt, so again my advice remains same. You have to go through the previous concept, first understand those and then come back to your exercise. So students, now we end here. Now I'll meet you in your next class with a new chapter. Till that, bye bye. Have a good day.